Okay, good day everyone. Today we are taking mathematics, and the topic we are looking at, as you can see, is set theory. I'm going to be breaking the class into 3 parts, and that's why I have called this part 1. Now, I'm sure you must have heard that before, but you may not have a grasp of what set is. Now, let's assume that you have a pen, a book, and a bag. Now, a pen is an object, a book is an object, a bag is an object. Now, if you put them together, you can't call it set. Why? Because they don't have the same characteristics. So, but if I have a red pen, a blue pen, a green pen, now everything is pen, so I can say a set of pen. Why? Because they have similar features or characteristics. So, set is the collection of objects with similar features. So, if you define set as just collection of objects, you have not completed that definition. You have to put of similar features. That's why you can say a set of shoes, a set of bag, a set of clothes. They have to have similar or the same characteristics for it to be a set. Now, having said that, so the next thing, that is, we said set is the collection of objects with similar features or characteristics. Another word for features is characteristics. So the next thing we are going to look at is the types now of sets. Now, I will classify this as types of set because I want to give us a full understanding of it. So, and we are going to be looking at, number 1, we are going to be looking at universal sets. Universal sets. We are going to be looking at union sets. We are going to be looking at intersection sets. We are going to be looking at complements of a set or prime set. Then we are going to be looking at a finite set. We are going to be looking at infinite set. And we are going to be looking at null sets. Null set, and we are also going to look at empty set. Then we are going to be looking at disjoint set. Or let me put disjoint set with this disjoint set. And then we are going to be looking at subset, and we're going to be looking at superset, and we're going to be looking at power set, and then we'll also look at, I can put number 13 here, we are going to look at singleton set. Singleton set. Okay, so we are going to look at all these 13 under this context. Now, the first one is universal set. Universal set. Universal set. Now, this universal set is also known as mother set. Mother as in mommy. Why? Because it is the set that contains all other sets. So it's it captures every other set. Every other set is contained in it. So a universal set is a set that contains all other sets. And so most of the time the sign is always given as this or something like this. So you have this sign to represent universal set. Okay. Number 2, we have union set. Union set. Now the union set is always represented by this sign, like a small letter U or a C that is sleeping. You understand? Small letter U. Now union set is that set that shows the elements, the combination of elements in two or more sets. Is that set that shows the combination of elements in two or more sets. Now I need to quickly say this, that when you have A and then you have this 1, 2, 3. Now this is set A having elements 1, 2, 3. Set A having elements 1, 2, 3. So whatever you have outside is the set. Whatever you have inside the bracket is called the element. So it means if I write B is equal to 2, 4, 8. So this is set what? Set B having elements what? 2, 4, 8. So another thing that came to my mind that I need to talk about is cardinality. Cardinality of sets, and also difference of two sets. I want to talk about those one here, and delta of a set. I want to talk about all of those here. Now looking at this now, so I said this is set A having element 1, 2, 3, and this is set B having element 2, 4, 6. So what is outside is the set. Whatever you have in the bracket are the elements. Now having said that, I said union set is that set that shows the combination of elements in two or more sets. Is that set that shows the combination of elements in two or more sets. Now look, take for example, so I can just say it shows the combination of elements from the word union, united, that is coming together, shows the combination of elements in two or more sets. Now take for example, let's say you have set A to be 1, 2, 3, and you have set B to be 4, 5, and then you have set C to be 5, 6, something like this. Now here, if you now have find A union B, find A union B union C, don't forget that this sign means union. Now A union B, what this means is that now what do I have in A and what do I have in B? Combine them together. That's the meaning of union. Union means combine the elements in A and B together. So what are the elements I have in A? 1, 2, 3. What are the elements I have in B? 4, 5. You have answered that question. Now look at this second one. A union B union C. That is the elements in A, in B, and in C. Combine them together. So you are going to have, what do I have in A? 1, 2, 3. What do I have in B? 4, 5. What do I have in C? 5, 6. But because I've written 1, 5, this 5 will stand for this one and this one. So you don't need to write it twice. So you just write the 6. You see that? So by doing that, you have answered that question. And that's what you mean by union set. Okay? Having got that, the next thing we want to look at is intersection set. That's number 3. Intersection set. Now, intersection set. Now, the intersection set is represented by a small letter N. It's represented by a small letter N. Intersection set is represented by a small letter N. Now, intersection set is talking about common elements. So, intersection set is that set that shows the common element between two or more sets. That is, so So I can say it shows the common elements. That's the keyword. The common elements in 2 or more sets. It shows the common elements in 2 or more sets. So here now, let's assume you have set A to be 1, 2, 3, and you have set B to be 2, 3, 4, and you have set C to be 2, 3, 5. Look at this. And then you are asked to find A intersection B, and then find A intersection B intersection C. Look at this. Now, having seen this, now you have set A having element 1, 2, 3, B having 2, 3, 4, C having 2, 3, 5. Now, A intersection B means that what do I have in A and it's also in B? What do I have in A and it's also in B? Now, what I have in A is 1, 2, 3. What I have in B is 2, 3, 4. So if you see, I have 2 and 3 in set A, I have 2 and 3 in set B. So they are common to the two sets. So that's your answer. Now, if you look at this, I have 1 in set A, but it's not in set B. So it's not a common element. I also have 4 in set B, but I don't have it in A. So it's not a common element. It is only 2 that you can find there, you can find there. 3, you can find there, you can find there. So it's common. That is the answer. That's what we call intersection. And of course, look at A intersection B intersection C. That is, we want to look at what is common in A, in B, and in C. So, what I have in A is 1, 2, 3. What I have in B is 2, 3, 4. What I have in C is 2, 3, 5. So, if you look at it very well, the only common element is I have 2 here, I have 2 here, I have 2 here. I also have 3 here, I have 3 here, I have 3 here. So, that is the answer. Now, what happens to this 5? I don't have 5 here. I don't have 5 here, so it's not a common element. Here, I have 3 and 2. I have 3 and 2. I have 3 and 2. I have 4 here. 4 is not here. 4 is not here. I have 1 here. 1 is not here. 1 is not here. That's why the answer is 2 and 3. Okay? That is that about intersection set. Let's move forward and then look at complement of a set. Complement of a set. Or you can also call it prime set. Prime set. Now, complement of a set. That's the next thing we are looking at. Complement of a set. Now, complement of a set, it is that set that shows the element that is in the universal set but not in a particular set. Is that set that it shows the elements in the universal set that is not in a particular set. Look at this. Now, at every time you have to do complement of a set, you must have your universal set. Now, let's take for example, now if you have your universal set to be given as 1, 2, 3, 4, and 5, and then you have set A to be 2, 3, and 4, and then you have set B to be 1, 3, 4, 1, 3, and 5, and then you are asked to find A prime. This is the sign for the prime. Then 2, B prime or B complement. Now they can use any of these two signs. If you have A raised to power, this, or B raised to power C, then it shows that you are finding complement of the set. So here now, The answer will now be, what do I have in the universal set that is not in set A? What do I have in the universal set that is not in set A? If you look at it very well, I have 1 here, I have 5 here, and they are not in A. That is the answer. The complement means that what do you have in universal that is not here? So at every given point, they must give you universal set for you to be able to do complement of a set. Look at this B prime. What do I have in the universal set that is not in B? I have 2 here, it's not here. I have 4 here, it's not here. So 2 and 4 is the what? Is the answer. So you see that? That's how to treat complement of a set. Number 5. We are looking at, okay, I omitted number 5 here. So what we're supposed to have is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, sorry for that. That's rightly numbered. I omitted 5. Okay, so number 5 now, we are looking at finite set. What is finite set? Finite set is a set that the elements in the set are countable. The elements in the set are countable. So finite set is the set that its elements are countable. Its elements are countable. Its elements are countable. Look at this. Now, for example, they can give you set A to be x dot dot x bar. You now have number of students in a class. Now you see that number of students in a class at every given point can always be counted. You can always know the number of students in a class. And so because you can always know the number of students in a class, it's a finite set. But, you know, for example, if they say number of sands in the sea, can you count the number of sand in the sea? No. So that is infinite set because it's uncountable, it's infinite. But anything that you can count is finite. So because it's finite, number of students in the class is finite. Or I can say we said B is number of cars in a garage. That's what we call finite set. Okay, the next thing we're now going to look at is infinite set. Now, infinite set, of course, is the opposite. Infinite set, its elements are not countable. Its elements are not countable. So, and I've given you an example previously when you have number of sands in the sea. So, can you count the number of sands in the sea? I don't know, but I don't think so. So, because it's uncountable, it is infinite set. Okay, having said that, the next thing we are going to be looking at is null set, empty set, or disjoint set. Look at this. Null set. Number 7. Null set / empty set. Now, of course, a set that contains no element is what we call null set or empty set. Now, but there's something that we always say. So most of the time, you always represent it with empty brackets. You always represent it with empty bracket because it's having nothing. But I need to quickly say that if you have a set that is having something like this, 0 is as good as saying it's an insignificant number. Now, like this set now is not empty. is having something, even though it's not significant. And so this type of set, you can call it null set. But this is an empty set. So all empty sets. So you always have a situation where they say there is difference between empty set and null set, because this one is containing something. Okay, I've established that. Now look at when you now have maybe A to be 1 and 2, and then B to be 3 and 4. You see this? And then I now ask you to find A intersection B. You don't forget that intersection means what is common. Now, do I have any common elements in these two sets? The answer is no. So it shows that A and B are disjoint. A and B are disjoint. So I'm trying to explain this disjoint. So that is nothing that is common. So that's why I put it together. Null set, empty set, or disjoint set. A set that contains no element. Okay? Having said that, the next thing we are going to look at is, okay, I've explained disjoint sets. 8 disjoint. I've merged it together with that. Okay, I've explained that already. So disjoint sets. Okay, so if I look at number 9, subset. Of course, when you say subset is a set that can be found in another set. A set that can be found in another set. So let's say, for example, you have something like this. So we say subset is a set that can be found in another set. A set that can be found in another set. So you look at this. Now what we are saying is that, let's say for example I have set A to be 1, 2, 3, 4, and then you have set B to be 1, 2. Look at this. Now you will see that everything I have inside set B is inside set A. 1 and 2 is here, and it's also A. In fact, A is even having more elements than this one. So if you look at it, B has element that A has, and A is even having more. So B is a subset to A. This is the sign for subset. It's a subset to A. Why do you say that? Because everything inside B, you can find it inside A. And A is still having more. So, like if I say you are a subset of your daddy, you have everything your daddy has, but your daddy has everything you have, plus more. Your dad has more. So you are just a component of your daddy, and then your daddy is having more things than you can have. So you are a subset. Or maybe if you look at a pregnant woman is a baby that is inside the woman. That baby is a subset. It can be human being that can be found inside another human being. So then number 10 is a superset. Superset. Now superset is the set that contains another set. So a set that contains another set. So let me put it that way. That is, A is a superset of B. Look at that. From this example, A is a superset of B. Why? Because A has everything B has, and A is still having more. So A is super to B. And this is the sign for superset. Okay? The next thing we are looking at is a power set. Power set. Power set. Power set. Okay? Now the power set is number 11. power set. Now, generally, power set is that type of set that has several subsets, or breaking a big set to several subsets. Now, here, what we are particular about is number of elements. The number of elements in any power set is 2 raised to power n, where n is the number of elements in a set. Now, 2 raised to power n. Let me explain further what I mean by this. Now, for example, if you have given A to be 1 and 2, they now ask you how many subsets can be found in set A. Look at this. So the moment you have this type of question, they are asking you about power set. Now, here now, what that means is we want to break this. So I will first write 1. That one can stand on its own. I will also write 2. 2 can also stand on its own. I will also write 1 and 2. And then I'll write empty set. You see that? Now, if you look at this, how many subsets is that? 4 subsets. Now, to confirm if this is true, you will say, okay, how many elements do I have inside set A? I have 2 elements. That means my n is 2. So number of subsets would now be equal to 2 raised to power n, which is 2 raised to power 2, these 2. And that is what? 4. 4 subsets. And if you count 1, 2, 3, 4, there are 4 subsets. Empty set must always be a set in any power set. Must always be a set. Let's take another example. Let's say we have given set P to be M, N, P. And then you ask how many subsets are in set P. Now, for you to know the number of subsets in set P, now you first say, okay, let me know number of subsets. Number of subsets is always 2 raised to power n. And so I can say 2 raised to power, how many elements do I have? I have 3 elements. That means my n is 3. So if I put 2 raised to power 3, 2 raised to power 3 does not mean 2 times 3. It means 2 times 2 times 2. And that's what? 8. So it means that I can break this set into 8 subsets. Now, how did I get this 2? The 2 is in the formula. How did I get this n? The n is the number of elements in the set. So because it's 3 elements, I put 3. Anywhere I see n, that gave me 8. That means I can break this set to 8 subsets. So let's do that. The first one will be m. The second one will be n. Each of the letters will stand on their own. The next one will be p. The next one will be mn. The next one will be mp. The next one will be np. Now you see what I'm doing, because you first say m standing on its own, n standing on its own, p standing on its own, then mn, then np, then np. You can't go backward. You can't do nn. You can't do pn. No, you must always go forward. Then after this one, you have the 3 together, mnp, and then you have empty set. So if I count 1, 2, 3, 4, 5, 6, 7, 8, you can see that it's 8 elements, which is equal to number of elements we must get. I will really advise you to practice a lot on this power set. As a matter of fact, I am going to give you this. You try it and then get back to us on this. Get back to us on this. Tell me, how many subsets can be found in this set? How many subsets can be found in this set? You can pause the video, quickly do that, and then you tell me the answer. Okay, if you pause the video, welcome back. The answer is the number of subsets you can find in it is 16. Is 16. Why? Because I have 4 elements. So 2 raised to power 4 means 2 in 4 places. 2 times 2 times 2 times 2. That's 16. Okay. I haven't said that. The next thing we are looking at, number 12, is singleton set. Now, some people used to call it singleton set. Well, whatever you call it, singleton set, singleton set. So a singleton set is a set that has only one element. A set with one element. Just one element. For example, if I have set A that is having just 3, it's just one element. So that's what we call singleton set. So, or I just have set N having only letter B. That's singleton set. Why? It's having only one element. Okay, number 13, cardinality of set. Cardinality of set. Now, when you are talking about cardinality of set, you are talking about number of elements that can be found in a set. Number of elements that can be found in a set, expressing it in figure. Let's say, for example, so I said number of elements in a set. That's it. So let's say, for example, that I have set A to be A, B, C, D. So if I want to find the cardinality means number of elements in A. See this small letter N, it means how many elements do I have inside set A? By doing this, you mean cardinality. So how many elements do I have? The answer is 4. I only have A, B, C, D. They are just 4 elements. For example, if I have B to be 1, 6, 8, 9, 10, 15, 25. Now I want to find the cardinality of B. How many elements do I have in B? That's the meaning of cardinality. So 1, 2, 3, 4, 5, 6, 7. Just 7 elements. So the answer is 7. That's what we mean by cardinality of a set. Now the number 14 we are looking at is a difference of 2 sets. Difference of 2 sets. Now when you are talking about difference of 2 sets, now difference of 2 sets, number 14. Difference of 2 sets. Difference of 2 sets is talking about when you have an element in a particular set that is not in another set. So of course the elements in a set that is not in another set. Now let me explain this. Let's assume you have set A to be 1, 2, 3, and you have set B to be 3, 4, 5, and then you are asked to find A minus B as number 1, number 2, B minus A. Look at this. So here A minus B means what do you have in set A that is not in B? What do I have in set A that is not in B? So look at the way you are going to do it. I have 1 in set A. Do I have it in B? The answer is no, so write it. I have 2 in set A. Do I have it in B? No, write it. I have 3 in set A. Do I have it in B? Yes. So that's all. You are finished. Somebody will ask me, what happened to 4 and 5? You leave it. Because what you are looking for is A minus B. A minus B means what you have in A that is not in B. Then B minus A now means what you have in B that is not in A. So let's look at how you are going to do that. You go to B and check. I have 3 in B. Do I have it in A? Yes. I have 4 in B. Do I have it in A? No. Write it. I have 5 in B. Do I have it in A? No. Write it. So 4 and 5. You see that? So that shows you that at every given point, your A minus B is not equal to what? B minus A. They are not the same thing. Your A minus B is never equal to B minus A. Okay, having said that, the last thing we are now looking at, but not the least, we say delta of a set. Now that's like a continuation of difference of two sets. Now what I mean is that you can be asked, using this same question, they can say, given that A is 1, 2, 3, and then B is 3, 4, 5. So find A delta B. Look at the sign, like a small triangle. Anytime you see this, anytime you see A delta B, A delta B is A minus B union B minus A. A minus B union B minus A. And don't forget, I have told you A minus B. A minus B means what you have in A that is not in B. So that is 1 and 2. Then B minus A, what you have in B that is not in A, that is 4 and 5. So combining it together, you are going to have 1, 2, 4, and 5. That's it. So that's what you have. And that has come to the end of this part of set theory. I'm going to be doing the part 2 of set theory.